Okay, we're ready for notes for 1C for the Math 4 course. In this section, we will be determining key features of graphs and describing the parent and transformations of their functions. That's going to be the big thing, is the transformations of all of these parent functions that we've been looking at. All right, for starters, vertical translations. I'm just going to kind of leave this there. Vertical translations mean that there is something, let me get my red pen going here. There's something added on to the end of the function. In other words, if this was the absolute value of x, then absolute value minus 4 is going to drop it down 4 units. And absolute value of x plus 3 is going to move it up 3 units. It's still going to, the v is still going to look the same for the absolute value, but it's moving up or down. Same thing is happening over here. Square root of x, there's that weird half parabola going on there. If I move it up, square root of x plus 2, it goes up 2. If I go square root of x minus 3, it goes down 3. So that on the tail end of it like that, it's going to shift it up and down. Now, when it's inside the parentheses, like this guy right here, understand that whatever is inside the parenthesis with the x, when you see it connected to x, you're thinking this is a left or right kind of deal. That's the way that the x-axis moves. And the thing that you're going to have to get used to is the idea that it goes in the opposite direction when it's in a parentheses with x. All right, that's the best way I know of it to describe it, is that when it's in the parentheses with x, you do the opposite. If I see x minus 2 squared, I'm going to take my parabola and I'm going to move it 2 units to the right, not the left. Again, we're going backwards of what the sign is. Over here we have x plus 3 quantity squared. Instead of going 3 right, we're going 3 left. Something similar is happening over here, and in the square root, when the bar extends over the top, it is as if there is a parenthesis around everybody inside. So this x plus 4 under the bar would be just like putting it in parentheses. And that means we're going to go 4 units, not to the right, but to the left. We're going to start over here instead of the origin. Likewise, x minus 2 under the bar means we're going to go 2 units to the right and not the left. So that's the whole deal with when it is in the parentheses with the x. Now, reflections, we're going to get a couple of things straight here, is that when the negative is outside, I'll circle that guy, it will reflect across the x-axis when it is outside, out front of the function. For instance, absolute value of x goes up, but negative absolute value of x, it is out in front, it is outside of the bars. It's going to flip over the x-axis. All right, square root function will do the same thing. If I stick, that is missing a negative out in front. And that will allow it to flip down there. Now, when the negative happens to be inside, in this case, it is inside with the x and not parked on the outside, it will reflect across the y-axis. So in this case, in black, I have y equals x cubed. But here, if I have y equals negative x inside the parenthesis with the cube, that means that it's going to flip on the y-axis. Likewise, over here, if I have square root of x and then I have square root of negative x inside the under the bar, it's going to flip on the y-axis, not the x. So it does matter where the negative, you're going to have to figure out a way to keep that straight. All right, vertical stretching. Probably you learned this about parabolas. And the idea is that if I have a number in front of my parent that is bigger than 1, it's going to stretch vertically. Vertical stretching if the number is bigger than 1. But if it's less than 1, like for instance 1/4 is less than 1, it will not vertically stretch, it will vertically shrink. I've also used the term vertically flatten. And so that's what happens when the number is outside. Now, when the number is inside, and I guess I need to make that note back up here, that he is outside. Just like the negative was outside of the parenthesis versus being inside. Now, we're going to talk about it being inside. And when that happens, it becomes a question of horizontal stretching or horizontal shrinking. Now, if the number inside is bigger than 1, then this, and now notice in black, this is where f of x is the parent function, absolute value of x. But when I put a number bigger than 1, it kind of does the same thing, whether it was inside in front or out front. They're both stretching toward up, as it were. But here they're saying if the number is between 0 and 1, then this is what they call horizontal stretching. And sometimes people will call it vertically flattening versus horizontal stretching. It means the same thing, honestly. We kind of have to be able to make that transition. If you're looking at multiple choice and you're thinking horizontal stretching and all you see is vertical flattening, you're going to have to realize that, yeah, they're talking about the same thing. It may sound like different English, but the result is the same. All right, now, you see, I don't have that many examples here, so I think I'll just plunge straight through and do this all in one video. All right, we are supposed to graph this guy given the parabola y equals x squared, and the x plus 2. Well, remember we said when something is inside the parenthesis with the x, we're going to do the opposite of what we expect. Plus 2 feels like it ought to go to the right, but we are going left 2. And here we are going down 3. The number on the outside like that at the very end talks about up and down in terms of y. And so we're going to, we haven't stretched or flattened or flipped or anything like that. So it is basically this parabola shifted over. Left 2 and down 3. 1, 2, 3. So my new vertex is right there. Now, this is where we can play that same game. Over 1, up 1. Over 2, up 1, 2, 3, 4. Over 3, 1, 2, 3, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 is one more. And likewise, we're going to have mirrors on the other side, mirror images of these same guys. And we can just make our little parabola. And there we go. Not perfect, but as well as I can do with an electronic pad and a stylus the size of a horse's leg. All right, now they said identify the domain and the range. And they're asking about the new graph. And so the domain is going to go forever left and right. So that is going to be that. But the range does not drop any lower than -3. That's that down 3 business. So we're going to start at -3 and go towards positive infinity. All right, we have a standard absolute value function, y equals absolute value of x. We're going to do 3 things to it. Because the negative is on the outside, we're going to flip on the x-axis. That -3 says we're going not to the left, but to the right. It's in parentheses. That those absolute value bars behave like a parentheses. And then the 1 says we're going up 1. So we're going to think of it as flipping down. Now, somebody asked the question at some point, Mr. G, what order should I do these in? Does order matter? And I would say technically order does matter. And you should do it in the order in which PEMDAS says you should do it, which means technically the -3 goes first. You would do that first, and then the negative, and then the 1. So we're going to move 3 units to the right, and then we're going to flip it down, and then we're going to go up 1, and that is going to be our new vertex. Now, we didn't stretch anything, but we are flipping it around this way. And so now the new domain and the range. Domain is not really changing. It's still forever in both directions. And the range gets up as far as +1 and goes negative forever. So we're going to start with the negative forever and go up to the 1, and the range does include the 1, so he gets a bracket. And so these are the kind of games that we're going to be playing with these functions. And this, when you see the square root bar and then you see the parentheses, that is like it would be on your calculator. That assumes that everybody inside the parentheses belongs under the bar, as it were. So we're going to actually do 2 things here. We're going to flip on x-axis. We're going to stretch by 2. This guy says we're going to go left 3. This guy says we're going to go up 1. All right, so we're going left 3, 1, 2, 3. We're going to flip the other way and stretch by 2, but ultimately we are still going up 1. So we're going to start there. Now, you can, if you get lost with this, you can do a T-chart. So you're going to want to start where the x is -3. And when I plug into this, that's going to give me the square root of 0. And even -2 times 0 is still 0. Plus 1, this is going to give me -3, 1. Well, hello, we're already there. All right, so when we move across, -2 is going to give me this. And, whoops, that is a +3. So that's going to give me the square root of 1, which is 1. Negative 2 times 1 is negative 2, plus 1 is negative 1. So we're going to go to negative 2 and negative 1. Now I want you to notice something here. That normally when we do the square root curve, it's like up 1 over 1, up 2 over 4. Well, notice that we went down not 1, but 2 and over 1. That means that this is the double effect. If I were to go down 2 and go over 4, I'm not going to go down 2, I'm going to go down 4 and over 4. 1, 2, 3, 4. Because if I were to come over here and do negative 1, actually look at something here. I've already predicted that negative 1 and 0 are going to give me weird answers. Because if I do this, I get negative 2 square root of 2 plus 1. Square root of 2? Where am I going with that? All right, let's jump all the way down to 1. And that is 1 plus 3, which is square root of 4 is 2. That gives me negative 4, negative 2 times 2. Negative 4 plus 1 is negative 3. And that is that guy right there. So the thing is that because there is a 2 up front, this guy is getting stretched twice as far, and because it's negative, it's going down instead of up. And so instead of over 1, down 1 over 1, it's down 2 over 1. You go twice as far. Instead of down 2 over 4, it's down 4 over 4. Instead of down 3 over 9, it's down 6 over 9. Actually, we should down 1, 2, 3, 4, 5, 6, and over 9 should be right there. So I could actually fix my graph a little bit. That didn't work out real well. All right, that's the general idea. And so that's what that should be looking like. Domain and range. Let's switch colors to make it stand out. Domain is going to start where x is negative 3 and go forever to the right. And my range is going to start where y is 1 and go down forever. Well, the down forever has to come first and then stop with y is 1. Now, please be careful, because even if you were to write it looking like this, 1 and negative infinity should never, ever, ever be on the right. It should always be on the, you're going left to right on the number line. And so negative infinity should never be on the right. So I'll get rid of that. All right, I believe that is it. Yes, that is it for your notes for 1C.